Hello students, welcome to CBSE Class 10 Maths 2025 Solved Paper. I'm Kunal Kohli. Section A. This section is 20 multiple choice questions, MCQs carrying 1 mark each. Let's start with question 1. If alpha and beta are the zeros of a polynomial 3x squared plus 6x plus k such that alpha plus beta is equal to minus 2 upon 3, then the value of k is a minus 8, b 8, c minus 4, d 4. Concept: relationship between zeros and coefficients of a quadratic polynomial. Explanation: my favorite part. In the polynomial ax squared plus bx plus c, the sum of zeros alpha plus beta is equal to minus b upon a, and the product of zeros alpha beta is equal to c upon a. Here, a is equal to 3, b is equal to 6, c is equal to k. Thus, alpha plus beta is equal to minus 6 upon 3 is equal to minus 2, and alpha beta is equal to k upon 3. Substituting these given conditions, minus 2 plus k upon 3 is equal to minus 2/3, which gives us k upon 3, which is equal to 4 upon 3, which gives us k is equal to 4. So the answer is D, 4. Now let's move on to question 2. If x is equal to 1 and y is equal to 2, is a solution of the pair of linear equations 2x minus 3y plus a equal to 0 and 2x plus 3y minus b equal to 0, then a is equal to 2b, b is equal to 2a is equal to b, c a plus 2b is equal to 0, or d 2a plus b is equal to 0. Concept: solutions of a pair of linear equations. Explanation: substituting x is equal to 1 and y is equal to 2 in the first equation, 2, 1, minus 3, 2 plus a is equal to 0, which gives us 2 minus 6 plus a is equal to 0, which gives us a is equal to 4. Substituting into the second equation, 2, 1 plus 3, 2 minus b is equal to 0, which gives us 2 plus 6 minus b is equal to 0, which gives us b is equal to 8. Since 8 is equal to 2 into 4, we have b is equal to 2a. So the answer is b, 2a is equal to b. Question 3. The midpoint of the line segment joining the points p minus 4, 5 and q 4, 6 lies on a x-axis, b y-axis, c origin, d neither x-axis nor y-axis. Concept: midpoint formula in coordinate geometry. Explanation: the coordinates of the midpoint xy are given by x1 plus x2 divided by 2, y1 plus y2 divided by 2. For p minus 4, 5 and q 4, 6, x is equal to minus 4 plus 4 divided by 2, which is equal to 0, and y 5 plus 6 divided by 2, which is equal to 5.5. Any point with an x coordinate of 0 lies on the x-axis. So the answer is B, y-axis. Question 4. If theta is an acute angle and 7 plus 4 sin theta is equal to 9, then the value of theta is A, 90 degrees, B, 30 degrees, C, 45 degrees, or D, 60 degrees. Concept: trigonometric ratios of specific angles. Explanation: solving the equation 4 sin theta is equal to 9 minus 7, which gives us 4 sin theta is equal to 2, which gives us sin theta, which is equal to half. Sin 30 degrees is equal to half. Theta is equal to 30 degrees. So the correct answer is B, 30 degrees. Question number 5. The value of tan square theta minus 1 divided by cos theta multiplied by sec theta is A, 1, B, 0, C, minus 1, or D, 2. Concept: trigonometric identities and reciprocal relations. Explanation: since 1 divided by cos theta is equal to sec theta, the expression is tan square theta minus, in brackets, sec theta into sec theta, which is equal to tan square theta minus sec square theta. Using the identity 1 plus tan square theta is equal to sec square theta, we get tan square theta minus sec square theta, which is equal to minus 1. So the correct answer is C, minus 1. Question 6. If HCF 9828 is equal to M and LCM 9828 is equal to M, then the value of N minus 7M is A, 0, B, 28, C, 98, D, 198. Concept: relation between HCF and LCM of real numbers. Explanation: 98 is equal to 2 times 7 square and 28 is equal to 2 square times 7. HCF M is equal to 2 into 7, which is equal to 14. LCM N is equal to 2 square times 7 square is equal to 196. Then N minus 7M is equal to 196. Minus 714 is equal to 196 minus 98 is equal to 98. So the answer is C, 98. Question 7. The tangents drawn at the extremities of the diameter of a circle are always A, parallel, B, perpendicular, C, equal, D, intersecting. Concept: properties of tangents to a circle. Explanation: the radius is perpendicular to the tangent at the point of contact. At the ends of a diameter, both tangents are perpendicular to the same line, the diameter, making them parallel to each other. So the answer is A, parallel. Question 8. In triangles ABC and DEF, angle B is equal to angle E, angle F is equal to angle C, and AB is equal to 3DE. Then the two triangles are A, congruent but not similar, B, congruent as well as similar, C, neither congruent nor similar, D, similar but not congruent. Concept: criteria for similarity and congruence of triangles. Explanation: since two pairs of angles are equal, the triangles are similar by AA similarity criterion. However, the side AB is 3 times DE, so the sides are not equal, meaning the triangles are not congruent. Answer D, similar but not congruent. Question 9. If minus 1 in brackets raised to n plus in brackets minus 1 raised to 8 is equal to 0, then n is A, any positive integer, B, any negative integer, C, any odd number, D, any even number. Concept: exponents of negative integers. Explanation: in brackets minus 1 raised to 8 is equal to 1 because the exponent is even. The equation becomes in brackets minus 1 raised to n plus 1 is equal to 0, gives us in brackets minus 1 raised to n is equal to minus 1. This is true only when n is an odd number. So the answer is C, any odd number. Question 10. Two polynomials are shown in the graph. The number of distinct zeros of both polynomials is A, 3, B, 5, C, 2, or D, 4. Concept: graphical interpretation of polynomial zeros. Explanation: the zeros of a polynomial are the x-coordinates of the points where its graph intersects the x-axis. Both curves intersect the x-axis at exactly two distinct points. So the answer is C, 2. Question 11. If the sum of first m terms of an AP is 2m square plus 3m, then its second term is A, 10, B, 9, C, 12, D, 4. Concept: arithmetic progressions, relations between an and Sn. Explanation: S1 is equal to A1 is equal to 2, 1 square plus 3, 1 is equal to 5. S2 is equal to A1 plus A2 is equal to 2, 2 square plus 3, 2 is equal to 14. The second term, A2 is equal to S2 minus S1 is equal to 14 minus 5 is equal to 9. So the answer is B, 9. Question 12. Mode and mean of data are 15x and 18x respectively. Then the median of the data is A. X, B. 11x, C. 17x, D. 34x. Concept: empirical relationship between mean, median, and mode. Use the formula mode is equal to 3 times median minus 2 times mean. Substituting the values, 15x is equal to 3 times median minus 2 in brackets 18x, which gives us 15x plus 36x is equal to 3 into median, which gives us 51x, which is equal to 3 into median, which gives us median is equal to 17x. So the answer is C, 17x. Question 13. A card is randomly selected from a deck of 52 playing cards. The probability of it being a red face card is A, 3 by 13, B, 2 by 13, C, 1 by 2, D, 3 by 26. Concept: probability of playing cards. Explanation: total cards 52. Face cards in each suite are Jack, Queen, King, 3 per suit. There are 2 red suits, hearts and diamonds. So red face cards is equal to 2 by 3 is equal to 6. Probability 6 by 52, which is equal to 3 by 26. So the correct answer is D, 3 by 26. Question 14. Which of the following is a rational number between square root of 3 and square root of 5? A. 1.414387954012 and so on. B. 2.326 under the bar. C. Pi. D. 1.857142. Concept: rational and irrational numbers. Explanation: square root of 3 is approximately 1.732 and 5 is approximately 2.236. So the option D, 1.857142, is a terminating decimal rational that falls between 1.732 and 2.236. So the correct answer is D, 1.85142. Question 15. If a sector of a circle has an area of 40 pi square units and a central angle of 72 degrees, the radius of the circle is A. 200 units, B. 100 units, C. 20 units, D. 10 square root 2 units. Concept: area of a sector of a circle. Explanation: area is equal to theta divided by 360 times pi r square. Substituting, 40 pi is equal to 72 divided by 360 times pi r squared, which gives us 40 is equal to 1 divided by 5 r square, which gives us r squared is equal to 200, which gives us r is equal to square root of 200, which is equal to 10 square root of 2 units. Correct answer D, square root of 2 units. Question 16. In the figure, PA is a tangent from P to a circle with center O. If angle POB is 115 degrees, then angle APO is equal to A, 25 degrees, B, 65 degrees, C, 90 degrees, D, 35 degrees. Concept: geometric properties of tangents and angles. Explanation: angle OAP is equal to 90 degrees, radius perpendicular to tangent. Angle AOB plus angle POB is equal to 180 degrees, linear pair, which is equal to and gives us angle AOB is equal to 65 degrees. In triangle AOP, angle APO is 180 degrees minus 90 degrees plus 65 degrees, which is equal to 25 degrees. So the correct answer, A, 25. Question 17. A kite is flying at a height of 150 meters from the ground. It is attached to a string inclined at an angle of 30 degrees to the horizontal. The length of the string is A, 100 square meter 3 meters, 300 meters, C, 150 square root of 2 meters, D, 150 square root of 3 meters. Concept: applications of trigonometry, sine ratio. Explanation: sine 30 degrees is equal to opposite height divided by hypotenuse string, point half, which is equal to 150 divided by string, which gives us string is equal to 300 meters. So the correct answer is B, 300 meters. Moving on to question 18. A piece of wire 20 centimeters long is bent into the form of an arc of a circle, radius 60 pi centimeters. Question 18. A piece of wire 20 centimeters long is bent into the form of an arc of a circle, radius divided by pi centimeters. The angle subtended by the arc at the center is A, 30 degrees, B, 60 degrees, C, 90 degrees, or D, 50 degrees. Concept. Relationship between arc length, radius, and central angle. Explanation. Arc length is equal to theta divided by 360 multiplied by 2 pi r. Point 20 is equal to theta divided by 360 times 2 pi times 60 divided by pi, which gives us 20, which is equal to theta into 120 divided by 360, which gives us 20 is equal to theta divided by 3, which gives us theta is equal to 60 degrees. The correct answer B, 60 degrees. Question 19. Assertion A. The probability of selecting a number at random from 1 to 20 is 1. Reason are, for any event E, if PE is equal to 1, then E is called a sure event. Concept. Sure events in probability. Explanation. Assertion is true because selecting any number from the range 1 to 20 is certain. The reason correctly defines a sure event and explains why the probability is 1. So the answer A, both assertion A and reason R are true, and reason R is the correct explanation. Question 20. Assertion A. If we join two hemispheres of same radius along their bases, then we get a sphere. Reason R, total surface area of a sphere of radius R is 3 pi r squared. Concept. Surface area of solid spheres and hemispheres. Explanation. Assertion is true. Two hemispheres make a sphere. However, reason is false because the surface area of a sphere is 4 pi r squared, not 3 pi r squared. So the answer C, assertion A is true, but reason R is false. And now we've reached section B. This section has 5 very short answers, VSA type questions carrying 2 marks each. Question 1. If x costs 60 degrees plus y costs 0 degrees plus sin 30 degrees minus cot 45 degrees is equal to 5, then find the value of x plus 2y. Concept. Trigonometric ratios of standard angles. Explanation. Substitute the specific values for the trigonometric functions. Cos 60 degrees is equal to half, cos 0 degrees is equal to 1, sin 30 degrees is equal to half, and cot 45 degrees is equal to 1. The equation becomes x half plus y 1 plus half minus 1 is equal to 5. Simplifying this gives x divided by 2 plus y minus half is equal to 5. Multiplying the entire equation by 2 to remove the denominators results in x plus 2y minus 1 is equal to 10, which simplifies to x plus 2y is equal to 11. So, the correct answer, x plus 2y is equal to 11. Alternate question. Evaluate tan square 60 degrees divided by sin square 60 degrees plus cos square 30 degrees. Concept. Evaluation of trigonometric expressions using standard values. Explanation. By substituting the standard values of tan 60 degrees is equal to square root of 3, sin 60 degrees is equal to square root of 3 divided by 2, and cos 30 degrees is equal to square root of 3 divided by 2. The expression is rewritten as in bracket square root of 3 squared divided by in bracket square root of 3 divided by 2 squared. This simplifies to 3 divided by 3/4 plus 3/4, which is 3 divided by 6 divided by 4, or 3 divided by 1.5. So the correct answer is 2. Question 22. Find the zeros of the polynomial bx is equal to x squared plus 4 divided by 3x minus 4 divided by 3. Concept. Zeros of a quadratic polynomial via factorization. Explanation. The polynomial can be rewritten by taking 1 divided by 3 as a common factor to get 1/3 in brackets 3x squared plus 4x minus 4. Splitting the middle term results in 1/3 in brackets 3x squared plus 6x minus 2x minus 4, which factors into 1/3 in bigger brackets 3x, smaller brackets x plus 2 minus 2, smaller brackets x plus 2, close the bigger brackets, is equal to 1/3 small brackets 3x minus 2, x plus 2. Setting these factors to 0 gives the solution x is equal to 2/3 and x is equal to minus 2. Answer: the zeros are 2/3 and minus 2. Question 23. The coordinates of the center of a circle are 2a, a minus 7. Find the values of a if the circle passes through the point 11 minus 9 and has a diameter of 10 square root of 2 units. Concept: distance formula and circle properties. Explanation: since the diameter is 10 square root of 2, the radius is 5 square root of 2 units, making the square of the radius 50. Using the distance formula between the center 2a, a minus 7, and the point 11 minus 9, we set up the equation 2a minus 11 squared plus a minus 7 plus 9 squared is equal to 50. This simplifies to 2a minus 11 squared plus a plus 2 squared is equal to 50, which reduces the quadratic equation to a squared minus 8a plus 15 is equal to 0. Factoring this gives a minus 5, a minus 3, 0. Answer: a is equal to 5, 3. Question 24. If triangle ABC is similar to triangle PQR, in which AB is equal to 6 centimeters, BC is equal to 4 centimeters, AC is equal to 8 centimeters, and PR is equal to 6 centimeters, then find the length of PQ plus QR. Concept: similarity of triangles and ratios of corresponding sides. Explanation: for similar triangles, the ratio of corresponding sides is equal. Explanation: for similar triangles, the ratio of corresponding sides is equal. AB divided by PQ is equal to BC divided by QR is equal to AC divided by PR. Substituting the known values gives 6 divided by PQ is equal to 4 divided by QR is equal to 8 divided by 6. Solving these proportions, we find PQ is equal to 4.5 centimeters and QR is equal to 3 centimeters. The sum is then 4.5 plus 3, which is equal to 7.5 centimeters. The answer: PQ plus QR is equal to 7.5 centimeters. Or, alternate question: in the given figure, QR divided by QS is equal to QT divided by PR and angle 1 is equal to angle 2 show that triangle PQS is similar to triangle TQR. Concept: similarity criteria SAS and properties of isosceles triangles. I used to love isosceles triangles. Explanation: in triangle PQR, since angle 1 is equal to angle 2, the sides opposite them are equal. So PR is equal to PQ. Substituting PQ for PR in the given ratio yields QR divided by QS is equal to QT divided by PQ. Since angle 1 is common to both triangle PQS and triangle TQR, the triangles are similar by side angle sides. SAS, similarity criterion. Answer: triangle PQS is similar to triangle TQR. And now we move on to question 25. A person is standing at B outside a circular ground at a distance of 26 meters from the center of the ground. He found that his distances from the points A and B on the ground are 10 meters. PA and PB are tangents to the circle. Find the radius of the circular ground. Concept: tangent properties and Pythagoras theorem in circle. Explanation: the radius OA is perpendicular to the tangent PA, so angle OAP is equal to 90 degrees. In the triangle OAP, applying the Pythagoras theorem gives 26 square is equal to OA square plus 10 square. This results in OA is equal to square root of 676 minus 100, which is equal to square root of 576, which is 24. Answer: the radius is 24 meters. And now let's move on to section C. Section C is where you can really score because it has 6 short answers, essays, type questions carrying 3 marks each. Question 26. In the given figure, O is the center of the circle and BCD is tangent to it at C. Prove that angle BAC plus angle ACD is equal to 90 degrees. Concept, properties of tangents and radii in a circle. Explanation. In triangle OAC, since OA and OC are radii, OA is equal to OC, which implies that angle OCA is equal to angle OAC. The radius OC is perpendicular to the tangent BCD at the point of contact C. So OCD is 90 degrees. This angle can be split into OCA, angle OCA, plus angle ACD, which is equal to 90 degrees. Substituting angle OAC for angle OCA, we get angle OAC plus angle ACD, which is equal to 90 degrees, which is equivalent to angle BAC plus angle ACD, which is equal to 90 degrees. So the answer, angle BAC plus angle ACD is equal to 90 degrees. Alternate question. Prove that opposite sides of a quadrilateral circumscribing a circle subtended supplementary angles at the center of the circle. Concept. Angles subtended by tangents at the center of a circle. Explanation. By joining the center to the vertices and points of contact, we establish congruent triangles such as triangle OAP, which is congruent to triangle OAS, leading to equal sides. Angle 1 is equal to angle 2, angle 3 is equal to angle 4, angle 5 is equal to angle 6, and angle 7 is equal to angle 8. Since the sum of all angles around the center O is 360 degrees, we have 2 in brackets angle 1 plus angle 4 plus angle 5 plus angle 8, which is equal to 360 degrees. Since the sum of all angles around the center O is 360 degrees, we have 2 in brackets angle 1 plus angle 4 plus angle 5 plus angle 8, which is equal to 360 degrees. This simplifies to angle AOB plus angle COD, which is equal to 180 degrees. Opposite sides subtended supplementary angle, i.e. that is angle AOB plus angle COD is equal to 180 degrees and angle BOC plus angle AOD is equal to 180 degrees. Question 27. Prove that tan theta minus is equal to 1 plus sec theta cosecant theta. Concept, trigonometric identities and simplification. Explanation. Expressing tan theta and con theta in terms of sin theta and cos theta, the expression becomes sin squared theta divided by cos theta in brackets sin theta minus cos theta minus cos squared theta divided by sin theta in brackets sin theta minus cos theta. Now, combining this gives sin cube theta minus cos cube theta divided by sin theta cos theta in brackets sin theta minus cos theta. Applying the algebraic identity a cube minus b cube is equal to a minus b in brackets a square plus ab plus b square, and simplifying the results 1 plus sin theta cos theta divided by sin theta cos theta. So the answer is 1 plus sec theta cosecant theta. Or we don't end our theta so soon, we have a lot more for you. Or prove that sin A plus cos A divided by sin A minus cos A plus sin A minus cos A divided by sin A plus cos A is equal to 2 divided by 2 sin square A minus 1. What's the concept here? Algebraic manipulations of trigonometric fractions. Explanation. Taking the LCM of the denominators results in sin square A minus cos square A. The numerator becomes sin A plus cos A squared plus sin A minus cos A squared, which simplifies to 2 sin square A plus cos square A, or simply 2. Replacing cos square A with 1 minus sin square A in the denominator results in sin square A minus 1 minus sin square A, which is equal to 2 sin square A minus 1. So the answer is 2 divided by 2 sin square A minus 1. Question 28. Find the ratio in which y-axis divides the line segment joining the points 5 minus 6 and minus 1 minus 4. Also, find the point of intersection. Concept, section formula, and y-axis properties. Explanation. Let the ratio be k is to 1. Since the point of intersection P, 0y, lies on the y-axis, its coordinate is 0. Applying the section formula for x is to 0 is equal to minus k plus 5, k plus 1, which gives k is equal to 5. The y coordinate is then calculated as y is equal to minus 4, 5, minus 6 divided by 5 plus 1, which is equal to minus 26 divided by 6, which is equal to minus 13 divided by 3. Answer. The ratio is 5 is to 1 and the coordinates of the points of intersection are P, 0, minus 13 by 3. Question 29. Prove that 1 divided by square root of 5 is an irrational number. Concept, proof by contradiction for irrationality. Explanation. Assume 1 divided by square root of 5 is equal to P divided by Q, where P and Q are co-prime integers and Q is not equal to 0. Squaring both sides gives 5p square is equal to q square, which implies q square and q is divisible by 5. Letting q is equal to 5a, we find 25a square is equal to 5p square, meaning p square and p is also divisible by 5. This contradicts the fact that p and q are co-primes. So the answer, 1 divided by square root of 5 is an irrational number. Question 30. A room is in the form of a cylinder surmounted by a hemispherical dome. The base radius of the hemisphere is half of the height of the cylindrical part. If the room contains 1408 divided by 21 cube meters, if the room contains 1408 divided by 21 meter cube of air, find the height of the cylindrical part. Concept, volume of composite 3D solids. Explanation. Let the radius be r and the cylindrical height be h, where h is equal to 2r. The total volume is the sum of the volumes of the hemisphere and the cylinder. 2/3 pi r cube plus pi r square h is equal to 1408 divided by 21. Substituting h is equal to 2r gives 8 divided by 3 multiplied by 22 divided by 7 times r cube, which is equal to 1408 divided by 21, which simplifies to r cube is equal to 8, so r is equal to 2 meters. Answer, the height of the cylindrical part is 4 meters. Question 31. 2 dice are thrown at the same time. Determine the probability that the difference of the numbers on the 2 dice is 2. Concept, probability in a sample space of 2 dice. Explanation. The total number of possible outcomes when 2 dice are thrown is 36. The outcomes of the difference between the numbers is exactly 2 are 1, 3, 3, 1, 2, 4, 4, 2, 3, 5, 5, 3, 4, 6, 6, 4, totaling 8 favorable outcomes. Answer, the probability is 8, 36, which simplifies to 2, 9. Section D. This section has 4 long answers, LA, type questions carrying 5 marks each. Again, a lot of time to score. Question 32. Vijay invested certain amounts of money in 2 schemes A and B, which offer interest at the rate of 8% per annum and 9% per annum respectively. He received 1860 as the total annual interest. However, had he changed the amounts of investment in the 2 schemes, he would have received 20 more as annual interest. How much money did he invest in each scheme? Concept, pair of linear equations in 2 variables. Explanation. Let the amount invested in scheme A be x and in scheme B be y. According to the first condition, the total interest is 8x divided by 100 plus 9y divided by 100, which is equal to 1860, which simplifies to 8x plus 9y is equal to 1,86,000. According to the second condition, interchanging the amounts in 9x divided by 100 plus 8y divided by 100 is equal to 1880, since he receives 20 more, which simplifies to 9x plus 8y is equal to 1,88,000. Solving these 2 simultaneous equations yields the values for X and Y. Answer: money invested in scheme A is 12,000 and in scheme B is 10,000. Question 33. The diagonal BD of a parallelogram ABCD intersects in the line segment AE at the point F, where E is any point on the side BC. Prove that DF times EF is equal to FP times FA. Concept: similarity of triangles and the AA angle-angle criterion. Explanation: in triangle ADF and triangle EBF, angle GFA is equal to angle EFB because they are vertically opposite angles. Furthermore, angle ADF is equal to angle FBE because they are alternate interior angles. Given that AB is parallel to BC in the parallelogram ABCD, consequently, triangle ADF is similar to triangle EBF by the AA similarity criterion. From the property of similar triangles, the ratios of their corresponding sides are equal. DF divided by FB is equal to FA divided by EF. Cross multiplying gives the required result. Answer proved. Alternate question. In triangle ABC, if AD is perpendicular to BC and AD square is equal to BD times DC, then prove that angle BAC is 90 degrees. Concept: similarity of triangles and properties of right-angled triangles. Explanation: the given condition AD square is equal to BD times DC can be rewritten as the ratio AD divided by DC is equal to BD divided by AD. Given that AD is perpendicular to BC, we have angle ADB is equal to angle ADC is equal to 90 degrees. This establishes that triangle DBA is similar to triangle DAC based on the SAS similarity criterion. Similarity implies that the corresponding angles are equal. Specifically, angle DBA is equal to angle DAC and angle BAD is equal to angle DCA. By adding these equations together, it can be shown that angle BAC is equal to 90 degrees. Answer has been proved. Question 34. The perimeter of a right triangle is 60 centimeters and its hypotenuse is 25 centimeters. Find the lengths of other two sides of the triangle. Concept: quadratic equations and the Pythagoras theorem. Explanation: let the lengths of the two legs of the triangle be x centimeters and y centimeters. Given the perimeter is 60 centimeters and the hypotenuse is 25 centimeters, we have x plus y plus 25 is equal to 60, which simplifies to y is equal to 35 minus x. Applying the Pythagoras theorem, x square plus y square is equal to 25 square, or x square plus 35 minus x square is equal to 625. This simplifies to the quadratic equation x square minus 35x plus 300 is equal to 0. Factoring the equation results in x minus 20, x minus 15 is equal to 0, providing the values for the sides. Answer: the lengths of the other two sides are 15 centimeters and 20 centimeters. Question. Alternate question. A train travels at a distance of 480 kilometers at a uniform speed. If the speed had been 8 kilometers less, then it would have taken 3 hours more to cover the same distance. Find the speed of the train. Concept: quadratic equations and the relationship between speed, distance, and time. Explanation, and pay attention because this is genuinely one of the most asked questions and very easy to score good marks. Let the original uniform speed of the train be x kilometers per hour. The time taken to cover 480 kilometers is 480 divided by x hours. If the speed is reduced to x minus 8 kilometers per hour, the new time is 480 divided by x minus 8. The problem states the difference in time is 3 hours. 480 divided by x minus 8 minus 480 divided by x is equal to 3. This reduces to the quadratic equation x squared minus 8x minus 1280 is equal to 0. Solving this gives x minus 40, x plus 32 is equal to 0. And since speed cannot be negative, x is equal to 40. Answer: The speed of the train is 40 kilometers. Question 35. Find the missing frequency f in the following table if the mean of the given data is 18. Hence, find the mode. Table 11 to 13, 7. 13 to 15, 6. 15 to 17, 9. 17 to 19, 13. 19 to 21, f. 21 to 23, 5. 23 to 25, 4. Concept. Statistics, mean and mode for group data. Explanation. To find the missing frequency, we use the mean formula where mean is equal to sigma fi xi divided by sigma fi. Based on the table, sigma fi is equal to 44 plus f and sigma fi xi is equal to 752 plus 20f. Setting the mean to 18 gives the equation 18 is equal to 752 plus 20f divided by 44 plus f, which results in f is equal to 20. With f is equal to 20, the modal class is 19 to 21 because it has the highest frequency. The mode is then calculated using the formula mode is equal to L plus brackets f1 minus f0 divided by 2 f1 minus f4 minus f2 times h, where L is equal to 19, f1 is equal to 20, f0 is equal to 13, f2 is equal to 5, and h is equal to 2. Answer. The missing frequency f is equal to 20 and the mode is approximately 19.95. Section E. This section has 3 case study based questions carrying 4 marks each. Question 36, case study 1. A school is organizing a charity run where each round around a track is 300 meters. To make it challenging, organize increase the distance of each subsequent round by 50 meters. The total number of rounds planned is 10. 1. Write the 4th, 5th, and 6th term of the arithmetic progression so formed. 2. Determine the distance of the 8th round. 3a. Find the total distance run after completing all 10 rounds. Or b. If a runner completes only the first 6 rounds, what is the total distance he has run? Concept, arithmetic progressions, terms, and summation. Explanation. The distances of the rounds form an arithmetic progression AP with the first term a is equal to 300 and a common difference d is equal to 50. 1. Using the formula an is equal to a plus n minus 1d, the terms are a4 is equal to 450, a5 500, and a6 550. 2. The distance of the 8th round is calculated as a8 is equal to 300 plus 7 times 50 is equal to 650 meters. 3a. The total distance for 10 rounds is 3a. The total distance for 10 rounds is the sum S10 is equal to 10 divided by 2 multiplied by big brackets 2 small brackets 300 plus 9 small brackets 50 close big brackets is equal to 5,250 meters. B. For 6 rounds, the sum is S6 is equal to 6 divided by 2 multiplied by big brackets 2 small brackets 300 plus 5 small brackets 50, which the sources evaluate as 2,250 meters. Answer 1, 450, 500, 550. Answer 2, 650 meters. Answer 3a, 5250 meters. Answer 3b, 2,250 meters. Answer 1, 450, 500, 550. 2, 650 meters. 3a, 5250 meters. 3b, 2,250 meters. Question 37, case study 2. A brooch is made with silver wire in the form of a circle with a diameter 35 millimeters. The wire is also used making 5 diameters which divide the circle into 10 equal sectors. 1. Find the central angle of each sector. 2. Find the length of the arc ACP. 3a. Find the area of each sector of the brooch. Or b. Find the total length of silver wire used. Concept, areas related to circles, sector angle, arc length, and perimeter. Explanation. The circle has a diameter of 35 millimeters, meaning the radius r is equal to 17.5 millimeters. It is divided into 10 equal sectors. 1. The central angle of each sector is 360 degrees divided by 10, which is equal to 36 degrees. 2. The length of arc ACB is 1 by 10 of the circumference. 1 by 10 multiplied by 2 multiplied by 22 by 7 multiplied by 35 by 2 is equal to 11 millimeters. 3a. The area of each sector is 1 by 10 by pi r squared, which is equal to 1 by 10 multiplied by 22 by 7 multiplied by 35 by 2 multiplied by 35 by 2, which is equal to 96.25 millimeters square, or 385 divided by 4 millimeters square millimeters. B. The total wire used is the circumference plus the 5 diameters, which is 2 multiplied by 22 by 7 multiplied by 35 by 2 plus 5 multiplied by 35, which is equal to 110 plus 175, which is equal to 285 millimeters. So answer 1, 36 degrees. Answer 2, 11 millimeters. Answer 3a, 96.25 millimeters square. Answer 3b, 285 millimeters. Question 38, case study 3. Amrita stood near the base of a lighthouse and measured the angle of elevation to the top to be 60 degrees. She then climbed an observation deck 40 meters higher and noticed the angle of elevation to the top is 45 degrees. 1. If CD is h meters, find the distance BD in terms of h. 2. Find distance BC in terms of h. 3a. Find the height CE of the lighthouse. U square root of 3 is equal to 1.73, or B. Find distance AE if AC is equal to 100 meters. Concept, applications of trigonometry, heights and distances. Explanation. Let the vertical distance from the deck level to the top be h, CD. 1. In triangle BCD, tan 45 degrees is equal to h divided by BD is equal to 1. Then BD is equal to HM. 2. In triangle BCD, sine 45 degrees is equal to h divided by BC is equal to 1 divided by square root of 2. Thus, BC is equal to square root of 2HM. 3a. In triangle ACE, tan 60 degrees is equal to CE divided by AE is equal to h plus 40 divided by h. Now, solving square root of 3 is equal to h plus 40 divided by h gives h is equal to 20. Square root of 3 plus 1, which is equal to 54.6 meters. The total height CE is equal to 54.6 plus 40, which is equal to 94.6 meters. B. If the slant distance AC is 100 meters, then cos 60 degrees is equal to AE divided by AC is equal to AE divided by 100, giving AE equal to 50 meters. The answers: 1. HM, 2. Square root of 2 meters, 3A 94.6 meters, 3B 50 meters. And with that, we come to the end of Maths 2025 CBSE. This is Kunal Kohli signing off for now. Join us for many more papers and best of luck in your exams.